Welcome to Study Loop.
Welcome back to another cross product problem where we're trying to find the volume of a parallelepiped that have adjacent points P, Q, R, and S, where we can calculate three vectors used for our triple product calculation as PQ, PR, and PS. So then PQ is just Q minus P. That's 2 minus negative 2, 3 minus 1, 2 minus 0. PR is R minus P. That'll be 1 minus negative 2, 4 minus 1, and negative 1 minus 0. And lastly, PS will be 3 minus negative 2, 6 minus 1, 1 minus 0. Now, the textbook gives us a nice formula for volume as the absolute value of A dot with the vector B cross C. But instead of calculating a cross product and then a dot product, we can just plug in A, B, and C directly into our matrix here. So we can write 4, 2, 2, 3, 3, negative 1, and 5, 5, 1, and then calculate the cross product how we normally would with the values 4, 2, and 2 replacing I, J, and K. So this gives us, when we ignore the first column, 3 times 1 minus negative 1 times 5. And normally we would multiply this by I, but this time we don't have an I here, we have 4. Minus, then we ignore our second column, 3 times 1 minus negative 1 times 5, 3 times 1 minus negative 1 times 5, all multiplied by 2, plus, same idea, ignore the third column, 3 times 5 minus 5 times 3, all multiplied by 2. Since we don't have any i's, j's, or k's, this isn't a vector, this is a scalar, and so we can just add everything up. So we're looking at 3 minus negative 5 times 4 minus 3 minus negative 5 times 2 plus 15 minus 15 times 2. Adding this all together, we're looking at 32 minus 16 plus 0 is 16 units cubed using the triple product method. Thanks for watching.